So this is topic 2, page 238. You'll notice that this is in the new book. There was not a good old book of the old book to use a video for it. So I'm using the new book. So again, this is Connecting Rate of Change, page 238, topic 2. We've still been talking about U.S. shirts. And remember, the cost of U.S. shirts was $8 per shirt. You can represent this rate of change as a ratio of the vertical distance to the horizontal distance. We also know that that's slope on the graph. You can also determine the rate of change or slope from a table. So we are going to look at this a little bit more. So explain the meaning of each ordered pair in terms of the situation. So if we're looking for the point 0, 15, let me zoom in just a little bit. So if we're looking for the point 0, 15, so again, go along number of shirts and up to 15. That means the 0 is the X value, the 15 is the Y value. So the 0 represents 0 shirts, and the 15 represents the total cost. So the 0 is here, we go up, the 15 is the total cost, so $15. So for 0 shirts, it's $15. Remember, that's that design fee, or however you want to describe it. 1 shirt, so 1 would be here between 0 and 2. 1 shirt is somewhere between 20 and 25, but if you look at the table, it's $23. So it's for 1 shirt ordered, so 1 shirt is $23. This is called context. So you're giving the context of what those numbers mean. So let's write that in our notebook. So context is the meaning of the numbers in a problem situation. Okay, so context of this is giving what that number means. It's 1 shirt, $23. Okay, then it says use a right triangle to verify that the slope of the line is $8 per shirt. So remember, frequently we find the slope from our table. So again, do 23 minus 15. So if we do 23 minus 15, it's 8. So it's changing 8 for 1. So what it's wanting us to do is look at the table and look at the graph and make a triangle to verify that. So it's just those slope triangles that we've been doing. So if you go from 15 up to 23 and then over 1, 15, 16, 17, 18, 19, 20, 21, 22, 23. So that's a change of 8 over 1. And I know it's kind of hard to get that to squeeze in there, but so I'm just going to draw a little arrow. So it went up 8 and over 1, which, remember, rise over run, change of y over change of x. 8 over 1 is 8. And it's changing $8 per shirt. So if you were to give that context, you would just say $8 per shirt. All right, so this slope equation, or the slope formula, notice if we took those 2 points that we were just looking at, the 0, 15, and 1, 23, notice this is y2, so the second y value is 23, so they did 23, minus 15, 23 minus 15, that's where this number is. It's the first y value. Then we have x2, which is the second x value, which is 1. See where that came from? And then the first x value, which is 0. So 23 minus 15 is 8, which we did in the calculator just a minute ago. 1 minus 0 is 1. 8 divided by 1 is 8. So again, we've been using a lot of tables. So 0, 15, 1, 23. 23 minus 15 is 8. 0 minus 1 is 1. So then it would be 8 divided by 1. Oh, sorry, you couldn't see what I was writing. 8 divided by 1. Notice that's the same thing that they did. Some people don't like using tables. Some like to use this formula. So it would be a good idea in your folder to, or in your notebook, to write the slope formula. So if you have, we're going to say x1, comma, x2, and then I'll use a different color for the next one, and we'll do, oh, sorry, I just messed that up. That's y1. Sorry, I was thinking about changing colors. And then our second point, so this is point 2. This is point 1. So then it would be x2, comma, y2. Sorry, I had to sneeze. So the slope formula, we have it written right here. So it's y2, which is this red point. So y2 minus y1. So the y of the second point minus the y of the first point divided by, and it's x2. So notice the second point is first minus the first point, which is exactly what we did here. We did 23 minus 15 gave us 8. So it would be 23 minus 15, which also gives us 8. And then it's 1 minus 0, which is 1, which is 1 minus 0, which is 1. So it all comes from the same thing. We are just making sure that you have many ways to solve this. There's a person down here, Celie, I guess we'll call her name. We'll say her name. So she did 23 divided by 1. So she took 23 and divided by 1. Remember, that doesn't work because this is not proportional. So non-proportional. So she is incorrect. See the little thumbs down? So it's non-proportional. Remember, we know it's not proportional because it doesn't go through the origin. That was the topic that we did last. All right. Now let's look at this one. So we're going to practice some more on calculating from tables. So you could, if you wanted to, use this formula and just use this. But I'm going to continue the way that we've been doing, and I'm going to just do our little things right here. So 12 minus 9. 12 minus 9. Is 3. 18 minus 12 is 6. 30 minus 18 is 12. Okay, then we're going to do 8 minus 4 is 4. So again, you're always taking the second one and subtracting the first. 16 minus 8 is 8. 32 minus 16 is 16. Okay, so what I want you to notice about these are not going by constant amount. We've had some assignments and we've had some different problems that we've done that are like that, but we're going to talk about it again. So again, you're going to do the first set of change. So the first change for y is 3, divided by the first change of x is 4. So 3 divided by 4, change of y divided by change of x, is 0.75. But it doesn't look like it's the same, but watch what happens when you do 6 divided by 8. 6 divided by 8, 6 divided by 8 is also 0.75. And then we would do 12 divided by 16 is 0.75. So what's happening here is if you look back at this one, it's kind of like they skip some points in there. So like all of these ones went by 8 and then went by 1, But on this table that we just did, it's like they skipped some points. Because if you went from 6, or if you went, instead of going by 3, what's 3 up from 12? 12, 13, 14, 15. What's 4 up from 8? Half of 8 is 4, so 8, 9, 10, 11, 12. So you can see it's kind of like they skipped a point in there. So that's how they're ending up with larger gaps. They're just skipping points. All right. Now we're going to do one on this side, and then we will go to the next thing. Okay, so again, I'm just drawing all my little triangles. Okay, we're going to do the second number minus the first. 23 minus 25 is negative 2. 21 minus 23 is negative 2. Do you notice how this one says negative? Do you notice how these numbers are going down? I know most students don't like negatives, but we have to deal with them. Then it's 7, 8, 9, 10. So 1, 1, 1. 10 minus 9 is 1. 9 minus 8 is 1. 8 minus 7 is 1. So then it would be negative 2 divided by 1, which is negative 2. So now, let's again find the context. So this is just a number to us right now. We want to look at it in context. So it's going down 2 vitamins remaining in the bottle for every 1 day passed. So it's going down 2 vitamins for every 1 day. So if we're going to give context of those numbers, it would be 2 less vitamins per day. Okay, this one. Let's look back. So it's changing $3, $6, $12 for 4 number of carnival rides, 8 number of carnival rides. So then we want to find our rate, which is 0.75. So it's $3 per 4 rides. So then that means it is, oops, that green almost doesn't work. 75 cents per ride. So when you divide it the way we did, that's per ride. So it's 0.75 cents per ride. So that's our context for that one. Okay, last thing that we're going to talk about, and you could do these 2 problems down here. There's no context on those, so that's why I didn't really do those. But let's look at this one. So now we're going to talk about y-intercept and give it context. So if we look at this, it's talking about U.S. shirts again. And we're trying to find the y-intercept. Remember, the y-intercept is where it crosses the y-axis. So that point right there is 0, 15, just like we did at the beginning of the video. So 0, 15, we said over here when we gave our first context, is 0 shirts, $15. So that means the y-intercept is with 0 whatevers, 0 of the x value is $15. So let's look at this one. If we're draining a pool and it starts here, we're going to write it as an ordered pair. So the x, you remember x always comes first, so you're going to move along the x-axis, 0, and then you move up. So notice this line right here doesn't actually represent 1. This is 1. So this would be 0.5. This would be 1.52, 2.53, 3.54. So that would be 4.5. So 0 time for our context. The 4.5 is the water level in feet. So our y-intercept is where it crosses the y-axis. So there is 4.5 feet of water after 0 time. So in the beginning. Okay, so in the beginning there was 4.5 feet. All right. This video is almost 15 minutes, so I'm going to go ahead and stop. But you could again do these problems down here just finding your y-intercept. This one you can't actually find the y-intercept on this graph because it's somewhere way up here that it would cross.